Our next presentation is fine-tuning nitrogen fertilizer sources, rates, and cutoff times in organic high bush blueberry. Amit Basin from WSU.
Thank you for the introduction. Can you guys hear me? Or should I speak? Okay. So, hello everyone, and myself Amit, as they already introduced me. So today I'll be presenting my master's research, which is fine-tuning organic nitrogen fertilizer source, rate, and cutoff timings in organic high bush blueberry. And most of that will be repeated in the first experiment will be repetition what Dr. Bernardine Strick has told you guys. But in the second experiment, I'll try to focus on more of a nitrogen cutoff timing, what we saw in our experiment. So starting with a journal or a brief overview that Washington State is the leader in organic high bush blueberry production with representing or producing 50% of nation's organic blueberries, which is approximately worth $38 million. And largely the organic industry is based on Eastern Washington. A highly valuable organic blueberry industry, growers are struggling for their nutrient management plans because Eastern Washington has calcitic soils and they have a unique climate, which and the soil pH is also differs what it usually blueberry usually requires. For example, generally blueberry requires acidic soil pH which ranging between 4.2 to 5.5 and high organic matter, because under these conditions the predominant form of nitrogen is ammonium, which is desirable for blueberries. Whereas if we look for the native soils in Eastern Washington, the pH ranges between 7.5 to 8.3 with low organic matter. And under these conditions, rapid nitrification is happening, which is detrimental for blueberries. And again, other concerns were that how blueberry cultivars would respond to different organic fertilizer sources and at what rate, as rate keeps on changing as plant varies. But how these factors would play into Eastern Washington as it has different soil conditions and climatic conditions. So this all questions led to my experiment first, where we evaluated different commercial organic fertilizer sources to find out what would be an optimal nitrogen fertilizer source and rate for northern high-bush blueberry grown in high pH soils for Eastern Washington. And I do want to point out that despite having high pH soils in Eastern Washington, growers use sulfur prior to plantation to lower down the soil pH. And after plantation, they use acidified water to keep the pH low for the soil. However, no one ever actually evaluated the efficiency of these products. So in my first experiment, we look at 4 different organic nitrogen sources. The first one was Wiser, which was derived from decomposed vegetable. And the second one was blood meal, which is a byproduct of cow slaughter industry. And the third one is true fish emulsion, as Dr. Bernardine said, the same product. And the fourth one is a combination, which included 40% of blood meal and 60% of Wiser. And all these sources were recommended by the Growers Cooperative, where we conducted our trials. So they really wanted to see these only organic nitrogen fertilizer sources. And all these sources were applied at 3 rate, low, medium, and high, which is 50, 100, and 150 pounds of nitrogen per acre. And in addition to nitrogen, we also applied phosphorus and potassium at 43 and 82 pounds of nitrogen, respectively. For phosphorus, I use ProPhos as a fertilizer source, which is derived from rock phosphate. And for ProK, for potassium, I use ProK. And all these products were OMRI approved. So I set up the experiment as a randomized complete block design with a split experiment where main source or main plot was fertilizer source and the subplot was rate. And each treatment was replicated for 4 times, as you can see in my experimental design. And we started applying these fertilizers when the plants were at 5 to 10% of bloom, which is another general recommendation. And I do want to point out that blood meal was applied 15 days earlier than all the liquid fertilizers to facilitate its mineralization process, because it's a dry granular fertilizers, and it was applied with 4 parts of water. And all the liquid fertilizers were applied at bi-weekly timings, whereas blood meal was only applied twice in a season, where there was a difference between where a difference of 1 month between the fertilizer application, and all the fertilizers were applied around the ground. The data I collected, I have divided into 3 variables: plant variables, fruit quality, and soil property. For the time constraint, I'll be just focusing on some of the results I have collected. And in addition to all these all the variables which I told you, we also studied that how organic fertilizer are releasing ammonium or nitrate, and in what ratio they are releasing. So we used plant root simulators and installed them at medium rate plots on the slope of bed, and these simulators helped us to quantify the amount of nitrogen being released from all these organic fertilizers. So starting with the results, I have cumulative shoot growth, where I found out that in 2018, I found that wise organic treatment applied at high rate have the longest shoots. In July, it produced 74% longer shoots compared to all other treatments. And in August, it produced 72%. And in September, the end measurement, it was 68% longer. But when we took the readings in or measured the shoot growth in 2019, this trend was not repeated, and nothing was we didn't observe any difference between the treatments. However, I do want to point out that there was a huge variability experienced or seen in the fields, as there were large standard bar errors. So coming on to WIP production. So on the first column, I have my treatments, where I evaluated my data according to years and rates and different fertilizer sources. And first started with numbers of WIP production. We observed that a slight increase in 2019 compared to 2018, where there's only one increase of one WIP per plant, but no difference was observed in the rate category or in the source category. And now moving on to the yield, we did observe again differences between the years, where plant average yield increased in 2019 compared to 2018, but we didn't found any significant difference between the rate category. I do want to point out that as Dr. Bernardine mentioned earlier, that as soon we apply more fertilizer, the plant yield tended to decrease. As we can see, that lower category of nitrogen application has produced more fruits than the higher one. But no difference was observed between the sources. And if we have to look between the sources, true fish emulsion uh, performed better than the rest of the organic fertilizer sources. There's some format changes, sorry. And I'll just skim over the leaf and leaf macro and micronutrients, where we found that all the leaf macro and micronutrients were within the recommended range except copper. Copper was, for consecutively 2 years, it was below the recommended range. And we also found that nitrogen concentration in leaves increased with the higher rates of nitrogen application, which has been studied in many other literatures. But no differences were observed among the nitrogen sources. And we observed no signs of deficiency or nitrogen deficiency, I would say, in particular in the plants. And again, this variable were also showing yearly differences. Coming on to my results in firmness and berry mass, we did observe some differences in 2018, where the fruits were firmer, sorry, in 2019, where the fruits were firmer. And it could be because we harvested the fields earlier than it should be, because we wanted to synchronize our plans with the growers cooperative, and they started to harvest early. So we also had to go to the field earlier in 2019, when the berries were not fully developed, and which may have caused the reflection in our results. And with the rate of nitrogen application also, the more nitrogen we were putting, the firmer the berries were, which is another indication that it could be that berries were not fully developed. As more nitrogen that you put, the development of fruit or the berries are hindered. For the sources, we also observe differences, and in particular, the combination had the firmer fruits compared to all or across all the fertilizer sources. For berry mass, we also observe that the berry mass decreased in 2019, and another indication that berries were not fully developed when we started to harvested the plants. But no differences were observed among the rates or across the fertilizer sources. So starting with the soil properties, as you can know that nitrogen fertilizer application can impact soil pH, and we also wanted to study that how soil nitrate and ammonium was being separated in the soil from these fertilizer sources. So when we started our fertility trial, before starting the fertilizer application, the baseline soil pH was around 5, which was under the recommended limit, and soil nitrate was 4.6 milligram per kilogram, and ammonium was 11.83, which is good that ammonium was more than nitrate, which is desirable for blueberry, and electrical conductivity or EC was below the recommend or within the recommend. Actually, it's below the recommended range of 1.5 to 2 decisiemen per meter. But at the end of the fertilizer application, soil pH increased slightly, whereas the higher the nitrogen we were applying, the higher nitrogen we were applying, the lower the soil pH was going. But no difference was observed between the sources. So, and another concern which we found out that despite growers lowering down the soil pH, there's a rapid nitrification was happening in this soil, which is undesirable as it soil nitrate concentration shoot up from the baseline reading. And coming to the sources, we did find that there were some differences where combination had the highest or the higher soil nitrate concentration. And I want to point out that it could be an additive effect because combination was the treatment where 40% blood meal plus 60% of wise organic was applied. So it could be an additive effect. Coming to soil ammonium, it also the soil ammonium concentration in soil also increased with the rate of fertilizer application, and we did see some significant differences. Whereas we also observed some differences in sources also where wise organic had the highest soil ammonium content. And now coming to soil electrical conductivity, for all these rates, it was slightly above the recommended range of 1.5 or to 2.0 decisiemen per centimeter, but no harm was observed to the plants. So as I said that we wanted to look at how nitrogen is being released from all those organic fertilizer sources. We use plant root simulators where we measure the release of ammonium and nitrate. What we found out, there was no correlation or a strong relation between temperature and release of nitrate in the soil. And similar was observed in 2018. The graph above is from 2018 and the below graph is from 2019. So we did not observe any significant or strong relation between temperature and the release of nitrate from the soil. However, we observed that in 2019, the release of nitrate was lower compared to 2018, and this could be due to that 2018 was a warmer year compared to 2019. And now, and again, we found out that as soon as we stopped the fertilizer application, there was a dip seen in nitrification also, which indicates that these organic sources are important for plant fertility contributors, and the ammonium released from these sources may have been used by all the microorganisms and have been converted into nitrates. In comparison, if we see what was the amount of ammonium released from these fertilizer sources, it was consistently lower in both years, where it was below 5 micrograms per ml in both the years, where you can see the nitrate was around reaching from 5 to 20 in 2018 and 5 to 15 in 2019. So we wanted to see why this is happening. And when we graph the moisture and what we wanted to find out the relation of moisture with the nitrate or ammonium release, we found out that the growers were constantly irrigating the fields, which might have created a condition of both aerobic and anaerobic conditions, which could have led to that not so strong relation between the release of ammonium and nitrate from our products. So in summary for experiment 1, I do want to point out that perennial plants can store huge amount of nutrients in their tissues, and they respond really slow to fertilizer application. So further years of data collection is required to see how these plants are responding to nitrogen fertilizer application. And coming on to the leaf macro and micronutrients, we did not observe any difference between we did not observe any signs of nutrient deficiency in the plants. But we did observe that both soil and PRS data suggest that there is rapid nitrification is happening in the soil, which is not desirable for blueberry plants in long term. And now I'm moving forward to my second experiment, which is timing of nitrogen application. So availability of nitrogen is really critical during the growth period, and generally growers are advised to fertilize the plant starting from bloom to fruit maturity, as this is the period of rapid nitrogen uptake and demand in plant. However, post-harvest nitrogen application is not recommended, as it can reduce the fruit bud set or may lead to or may decrease the cold hardiness in fruiting bud by producing or stimulating vegetative growth late in the season, which can lead to winter injury in the fruiting buds. However, there has been studies which have indicated that if we are fertilizing the plants even after harvest, the plants have shown to increase their nitrogen concentration in leaves and in shoots also, and they can also contribute to the nitrogen storage pool of the plants, which can help in the or increase the longevity of the plants. And simultaneously, if we harvest the plant during that, or we apply nitrogen to post harvest, simultaneously there's a rapid growth is also occurring, which we can support through this post-harvest nitrogen application. So there are also benefits of post-harvest nitrogen application, as it can encourage lateral shoot growth, which can lead to additional fruiting buds in the plants, which in the following season may increase the yield of the plants. So this led to the objective, my second objective, where I had to see what are the implications or impacts of post-harvest nitrogen fertilizer application on plant growth, yield, fruit bud set, and cold hardiness. So the research question I asked, or what I wanted to ask is whether the post-harvest nitrogen application will hurt the blueberry fruit by decreasing their cold acclimatization or cold hardiness, or would it cause any winter injury in the plants, or in particular the fruiting buds? So to answer this question, we started another trial where we fertilize the plant based on the timing of nitrogen application with 4 treatments. The first treatment was control, where all the nitrogen was applied pre-harvest, and the second treatment was 80-20, where 80% of the nitrogen was applied pre-harvest and the remaining was applied post-harvest, same as 70-30 and 60-40. And for this treatment, we kept the rate at 116 pounds of nitrogen per acre, which was a constant throughout all the treatments. And the fertilizer source which we used for this experiment was Wise Organic. And similarly, we started applying fertilizers around 5 to 10% of bloom, which carried to late August in both 2018 and 2019. I set up the experiment as a randomized complete block design with 4 treatment, as I already said to you, and each treatment was replicated 4 times. In this experiment also, I collected the similar kind of data where I looked for the cumulative shoot growth, whip production, and average yield, again, leaf tissue nutrients, fruit quality, and the soil properties. But I'll just restrict myself for the all the data which I have already showed you. Plus, I've also taken the fruit bud set and cold hardiness data. As I told you that these post-harvest nitrogen application can impact fruit bud set in plants or can delay or decrease the cold acclimatization of fruiting buds. So coming on to the results, again for the shoot growth, we did not observe any difference between the treatments. But we did find out that the more later applications we were doing, the plants fertilized with 60-40 treatment as shown by the yellow line has longer shoots compared to all other treatments. And it could be possible because when the fruit is harvested, the shoot growth again starts in blueberry plants, which may have led to the increase in shoot growth in 60-40 treatment in particular. But there wasn't any difference across the treatments in both 2018 and in 2019. So again, for the whip production, we did not observe any differences between the treatments, not in the ear or at the treatment level. And coming on to the yield, again, we did not observe any difference, but there was a slight increase in 2019. And these plants are again following the yearly trend, so which may suggest that further years of data collection is required to study how these plants are responding to fertilizer applications and the timing related to fertilizer application. However, in average yield, we observed that 70-30 and 60-40 treatment in particular have higher yields in both the years, which may suggest that if we keep fertilizing these plants, we may see a difference in yield for the coming years, as it has been observed in many studies related to apples, where the later the fertilizer application was done, it gave a kickstart for the plants in the following season, which produced larger fruit, which increased the yield in apples. Coming on to fruit bud set, we did not observe any difference across the treatment and across the among the years also. So fruit bud set was, I think, mostly or largely controlled by the genetic makeup of the plant, or pruning has a big impact on that. So that's why we are not seeing the effect of our nitrogen application on fruit bud set, but we need to carry further years of data collection to give some conclusive results. Now coming again onto leaf macro and micronutrients, all the leaf macro and micronutrients were within the recommended range suggested for the Eastern Washington. And again, copper was below the recommended range for both 2018 and 2019. And no signs of nitrogen deficiency was observed in the plants. And these leaf tissue nutrient concentration was also following yearly effects. Coming on to firmness, we did observe a significant decrease in firmness in 2019. And this could be due to the fact that these berries were allowed to hang for longer in 2018, as the growers decided to pick the fruit through mechanical harvester, which allowed or delayed our operation to synchronize with their operation, harvesting operation, which may have led this decrease in firmness. But no difference was observed in control 80-20 or any other treatment. Again, the berry mass was similar for both the years and among the treatments as well. So now coming on to the cold hardiness, as I said that post-harvest nitrogen application may lead or may decrease the cold acclimatization or hardiness in blueberry fruiting buds. So in October, we exposed the blueberry buds starting from 14°F to -2°F. And we did observe some differences where we saw that there was bud damage due to these cold temperatures. And here the yellow bar represents the 60-40, the gray bar represents the 70-30, and the orange bar represents the 80-20, and the blue bar represents the control. We only saw the treatment differences at 3 degrees Fahrenheit, where 60-40 treatment had higher fruit bud damage compared to all other treatments. But again, there was no consistent pattern was observed in fruit bud damage, where you can see at 0 degree Fahrenheit, control control nitrogen application was having more fruit bud set. But I do want to point out an important part of this graph is that we started the fertilizer application or exposing the buds to cold injury from minus 14 degree Fahrenheit. But the first fruit bud damage was observed at 9 degrees Fahrenheit. So the plants withstanded 13, 12, 11, and 10 degrees Fahrenheit. And the first fruit bud damage in October was observed in 9 degrees Fahrenheit. Similarly, for November, we started exposing the buds to cold temperature starting from 7 degrees Fahrenheit to minus 19 degrees Fahrenheit. And similarly, there was no consistent pattern was seen, but the first fruit bud damage was observed at 1 degree Fahrenheit. And if we compare it to October, there was an 8-degree drop. And lastly, we exposed the blueberry buds in December, starting from minus 2 degree Fahrenheit to minus 18 degree Fahrenheit. And the first fruit bud damage was observed at minus 2 degree Fahrenheit, but no consistent pattern was observed across the treatment. So I was thinking that we are exposing these buds to really cold temperature, and the region may not experience this cold temperature. So I looked at the historical or the 28-year minimum and maximum temperature from 1990 to 2018 and found out that in October, the temperature was never below 25 degrees Fahrenheit. And in November, it also never dipped below 25 degrees Fahrenheit. But in December, it was around 20 degrees Fahrenheit, where it never went below 15 degrees Fahrenheit in 28 years. Whereas we observed our first differences in 9 degrees Fahrenheit in October, and in November we observed at 1 degree Fahrenheit, and in December at minus 2 degree Fahrenheit, which suggests that the temperature we use to expose this bud is unlikely to be experienced in this region, which may suggest that there is a possibility that we can continue post-harvest nitrogen application in these plants, particularly in early fruiting cultivars in Eastern Washington. And this graph also tells us that as the season is progressing from October, November, and December, the capability of fruiting buds to withstand cold temperature is also increasing. As you can see, in October it was 9 degrees Fahrenheit, and in November it was 1 degree Fahrenheit, and in December it was minus 2 degree Fahrenheit. So in conclusion of all these experiments, that we observe no signs of nutrient deficiency in these plants and no increment in fruit bud set also. But there may be a possibility that if we keep continuing this fertilizer application, we may see a differences in the coming years. And again, yield tended to increase in the later fertilizer application treatments. Further year of data is necessary to counter for the slow response of perennial to fertilizer application. And we did not observe any detrimental effect on bud acclimatization process because the region may not experience this cold temperature. But how these plants will respond if we use the mid-season cultivar or the late-season cultivar is largely unknown, so that we cannot recommend post-harvest nitrogen application in mid or late-season cultivars. And further research is required to see how these plants are responding when they are coming out of dormancy, when they are in their deacclimatization process in spring. So with that, I would conclude my presentation, and I would like to thank Northwest Center for Small Fruit Research and Blueberry Washington Commission for funding my research, and for all the fertilizer companies such as Wiser, Crewfish, and Ferticell for providing us the fertilizer material, and my graduate committee, Dr. Lisa Vasco-DeVetter, Dr. Joan, and Gwen Hoheisel, and all the small fruit team which helped me throughout my my experiments to continue with the fertilizer application in the field. And these are all the references. And if you have any questions, please let me know. Sure.
Thank you.
Your free samples there. Oh, there you are. Like your free samples there. Did you finding that are you putting copper on at that time to help kind of being acted as an antifreeze or a fungal resistant for winter damage?
So the question was whether I'm putting some any supplemental copper to reduce the fungal damage. No, we were not doing that. We did not put any additional or supplemental fertilizers.
Thank you. We'd like to go ahead and take a short break. But please come back. We'd like to get the next session started as quickly as close to 2:45 as we can. So if you want to just take a stand up and then come right back in, that'd be great.